So Python, unlike Java, has something called multiple inheritance and also a particular built-in called super that makes multiple inheritance possible. Multiple inheritance get very complicated, so pay careful attention. So let's first start with a little reminder. We have a definition of a class called myClass and some methods inside of myClass. But we make myClass here inherit from two different classes, another class and yet another class, with the hope of inheriting also from the methods that are defined in another class and the methods that are defined in yet another class. Okay, so we have typically a picture where my class inherits from another class and another class also inherits from yet another class. But this can lead to a lot of problems, especially with method overloading, because we might have some method that we're calling for an instance of my class, and that name is already defined in both another class and yet another class. So what do we do then? Do we define it? Do we use it? Do we use the another class version? Do we use the yet another class version? Do we use both? What if the graph is more complicated and has more complicated inheritance where, let's say, something like this happens and the method we're calling is defined a bit everywhere? How do we know which to actually execute? So you might think that this is very theoretical and never happens, but actually those diamond situations, so the cases where there is not a single path to object, occur all the time, literally all the time, as soon as you have multiple inheritance. So let's see why. Well, the main reason is that every class in Python inherits directly or indirectly from object. So you always have object at the top and then a bunch of classes that inherit from object. And in this case, directly is just another class and intermediate class. And inheriting from intermediate class is yet another class. And inheriting from both is my class. Okay, so here we have some diamond inheritance pattern that is indirect, if you want, because it's going through this chain here. The more direct diamond pattern is if you have a class A and you have two separate classes B and C inheriting from A, and then you have here D inheriting from both B and C. So this is the classic diamond pattern, and you can imagine what this part would look like for this diamond, but you can also imagine that there will be problem when we call a specific method on D that is defined on B and on C. So this is what I'm saying here. Method overloading becomes very tricky. So if we have a common method that is not defined on my class, but is defined on another class, an intermediate class, and yet another class, then we're in trouble, right? Because we don't know which one to actually execute. If we need to execute the one that's defined on another class or yet another class, or maybe even the one on intermediate class. So you have a problem as soon as one of those two is defined, while this one is. If the two are defined there, you can sort of tell that the method that's defined on yet another class always wins over the method defined on intermediate class, because this guy here, this class here, is more specific than this one. So whenever you're calling a common method on an instance of yet another class, you should just ignore the method that has been defined for instances of intermediate class. Okay, so if the question becomes, which do you execute? And actually, this question is not very good in some cases, because sometimes you want to execute more than one of them. The typical example for this is underscore underscore init, so the constructor, which is a name that you will use again and again. So basically, all the methods, all the classes here will define an init, or almost all of them. And you typically don't just want to execute one of them. You want to execute pretty much all of them, because this initializes your object, and part of your object might be initialized in the less specific classes. Okay, so the way you think of it is you have an object that has an init that constructs it, and then you inherit from that initial class, and the the constructor here only specifies how to build the parts that add to the original class, and so on and so on. So each time the init only specifies this extra layer that you're adding with the new class. So this means that in the end, when you call the init for this guy, you want to rely on the inits that are defined before. And you really want to do this. You want to rely on the previous inits and not do everything at this level because of the encapsulation principle. So this means that the encapsulation principle means that you should be able to use another class or yet another class without looking at the code that defines yet another class or another class, but just at its interface. Okay, so you don't want to have to go look at the code that defines intermediate class. You just want to know about another class and yet another class. Okay, and this is already tricky in this simple graph, but the graphs can be a lot more complicated. So you can really have very, very complicated dependencies between those classes, and really multiple inheritance starts becoming very tricky. Still, Python does it. So Python can handle multiple inheritance. So how does it do it? Well, the solution that Python uses is called the method resolution order. And this solution is to take this complicated dependency graphs that I've been drawing, and reduce them to a linear graph. So reduce them sideways if you want, so that you introduce all kinds of orders between the different classes, between the different superclasses of my class, so that you can really say, this is the next one, this is the next one, this is the next one. So it becomes a linear inheritance problem, if you want. But it's quite tricky because you want to make it in such a way that encapsulation works. So you want to really make it so that whenever you define a class, you only need to rely on the base classes to know what to do. So let's see this. So here we have MC. So MC depends on another class, and this depends on yet another class, and this guy depends on intermediate class, and they both depend on object. Okay, so essentially what Python will do is that it will take these base classes here, so AC and YAC, it will take that as votes or as decisions that are taken in the ordering. So AC here is specified before YAC. So this means that AC should come before YAC in my order. And because MC inherits from AC and YAC, it takes this really as a decision that this ordering should be true. So here I have another ordering that says that AC inherits from object, and here I have yet another decision that IC inherits from object, so it should come before in the ordering, and finally YAC inherits from IC, so this guy should come before. So if you look all together, if you want to define a linear ordering that satisfies all those relations, well, in this case, it's very simple. So my class needs to be below AC, needs to be below YAC, and YAC needs to be below IC. So I've used this guy so far, and then IC needs to be below object. And if I do all this, then of course naturally I satisfy also that AC is less than object by transitivity. So this becomes my new ordering. So I have now MC that depends on AC, that depends on YAC, that depends on IC, and this guy depends on object. Okay, so it will essentially do everything that it was doing with linear inheritance, but with this graph now, this dependency graph. Still, there is one unsolved problem so far, which is what to do when you actually want to chain call all the different methods. So for the case of constructors, for instance. Before we get there, let's see another example of the method resolution order for a more complicated object. So I have here object, and A inherits from object, B inherits from A, C inherits from A as well, and here D inherits from B and C. On the other hand, E inherits from object, and F inherits from C and E, and finally G inherits from D and F. So we have this diamond here that is defined that we saw earlier, and then we have a more complicated diamond, and then we have further inheritance from G. And somehow, so Python takes all of those as votes. So the linear ordering that we have at the end should respect all the relations that are defined here. But if you think about it, you will see that there are some decisions to take. For instance, how should E compare to B, for instance? So that's not specified here. And I just said that the partial order here needs to be linearized. It's more here than just the partial order. So it's also, Python takes an inheritance relationship as a vote in the partial order. So G comes before D, but it also takes the ordering here as a vote. So B should come before C, and C should come before E because it's defined here. Okay, so I really have also those arrows that are present. So the way Python will do it is that it's a recursive definition for this method resolution order. So if it has to define the method resolution order for G, it will look at the base classes, which are D and F, look at the method resolution orders for D and F. So this will linearize in some way. For instance, D inherits from B, inherits from C, inherits from A, inherits from object. So this is the method resolution order for D. The method resolution order for F would be quite simple. It would be F depends on C, so that's forced. And then it's not clear whether A should come first or E should come first, right? But it turns out that A comes first, and then we go for E, and then we go for object. And it also, so it takes the method resolution for D and F, because those are the two base classes of G, and also a vote that D should come before F. Now, with all this information, somehow it will merge all of this into one method resolution order. And in this case, you see that we start with G, of course, and then we go for D, and then B, and then before we can get to C, we need to go to F, because F has to come before C. And after that, after C, then it's pretty straightforward that it will have to be A, E, and object. So you see here the whole linearization of this partial order together with all the votes that are given at the base level. So all those votes, D comes before F, C comes before E, B comes before C. Okay, so this is quite complicated, but whenever you have a class, you can call the MRO method, and this will give you a list of classes. And here I've just asked Python to print the names of those classes. I haven't fully specified the algorithm, the resolution algorithm, which is called C3, but this is really good enough. It's, as I said, it becomes very complicated. Now, there is one problem, and the problem is when you use chain calling. And so let's first see, so chain calling means you want to call all the previous ones, not just call one method, but call all the methods with that name in the inheritance graph. So let's see how you already have that problem with linear inheritance. So let's say we have a constructor for all kinds of classes that are in a linear inheritance relationship. So we have object, and we have A inheriting from object, B inheriting from A, and C inheriting from B. And we want to construct an object of type B. So we'll call the constructor for C, so we'll call init for C. But as I was saying earlier, we want this constructor to rely on the constructor for B. And we want the constructor for B to rely on the constructor for A, and the constructor for A to rely on the constructor for object. So one naive way to do it is like this. Have the constructor for C, so this init here, do something with the data that's associated to C exclusively, and then call the constructor for B with the data that's associated to an object of type B. And then similarly for this constructor, call the constructor for A. Now, don't do this. So we could access particular constructors with this way. So the class name.init would refer to the particular constructor, but you should not do it because this does not allow subclassing in the context of multiple inheritance. So we'll see in a second why. This won't really work anyway if you're doing pure multiple inheritance. And the reason here is that if you are calling, if you have this diamond pattern now, so you have object, and as I was doing earlier, this is the canonical diamond inheritance pattern. So we have B and C and D. So if we're calling the constructor for D, so let's print D, and let's then call the constructor for B, and the constructor for B will call the constructor for A. Well, if you do this, then you're just bypassing C, right? So if I construct a new object of type D, then I'll print DBA, and C is missing. So that's not good if we explicitly call using the class name. All right, so the solution might be, well, we need to call two constructors. We need to call the constructor for B and the constructor for C, because D is both an instance of D is both an instance of B and an instance of C. Well, if you do this, you will see that, so let me draw quickly the graph. So B, C, A, and of course object here. So if we do this, then we'll call the constructor for D, and this will call the constructor for B, which will call the constructor for A. So this explains this part. But then we call the constructor for C, and the constructor for C also calls the constructor for A. Okay, so now we print CA. And there's no way around it, because you want class B to work on its own, and you want class C to work on its own. So they both have to call the constructor associated to A. Now, this becomes a problem because when you inherit from both B and C to construct D, well, you want to call the constructor for B and the constructor for C, and they both call the constructor for A. So this becomes a problem if you name explicitly which constructor you're using. Okay, so if you do things like this, A dot B dot C dot init, it's not a problem anymore if instead of doing of naming explicitly the constructor, you just say take the next thing in the method resolution order. So in this case, if you have an object of class B, the next class in the method resolution order would be A. So we can call the constructor of the next class in the method resolution order, and that would work. If you are at C and want to call the next class in the method resolution order's constructor, that would be the constructor of A. But if you are constructing an object of type D and calling the constructor of the next class in the method resolution order, this becomes the constructor of B. But from there, you can call the constructor of the next class in the method resolution order without changing the code, and this becomes this guy. Remember? Because the method resolution order for D is D, B, C, A. So, and from there, you want to call the constructor again, the next one, in the method resolution order, and this would be the constructor of A. So if you do it this way, then you have to use super. And super does exactly what I just did. It says, look at the next guy in the method resolution order. And if you do it this way, then you indeed print what you should. So you print DBCA. And this works in the sense that every constructor is called just once, and you're not calling twice the constructor for A. So how does super work? Well, as I just said, it will construct it. Okay, so it will linearize the whole inheritance graph. So I have object here A. So B depends on A, C depends on A, and D depends on B and C, and I have E here. Now F depends on C and E. I've already drawn this graph. So, and G depends on D and F. So this is linearized, and this is linearized by the method resolution order to G, D, B, F, C, A, E, and object on top, of course. So what it will do is that it will navigate this graph by going through things in the order determined by the method resolution order. So it will go to F, then to C, then to A, then to E, then to object. Okay, so it will navigate everything. When you have self here that is of type G, then if you are looking at super, then some class, then an instance of G, it will give you the next object in the method resolution order of G, the next class, sorry, in the method resolution order of G, starting from the class there. Okay, so if I try super B self, where self is an instance of G, then this would effectively be F. Okay, because the next guy here is F. So this means that in the constructor of B, I should have something like this. Instead of calling a.init, I will call super B self.init. And this will work whenever I'm constructing an object of type B, but also whenever I'm constructing an object of type G. And also actually whenever I'm constructing an object of type D, because the super of B in this case would become C. Okay? So if this is of type G, then this is true. And if I do super B self, where self is of type D, then this would be C, the C class. Okay, so the general recipe, if you want, is that super is called in some method of some class, and this is always the syntax that you should use: some class, comma, self, and then some method that is called from that is defined in one of the bases. So really, the point here is that this code does not need to change when you inherit from it, but when you inherit from it, you will end up calling this code with a different instance of self, which will change the result of calling super here. So that's really the key thing. Now, there are two things that are important, and they have to do with signatures. So the arguments you pass to some method. So you see here that I have some method self, and here I call some method without self. And that's because the result of super is that the method remains bound. So what's called bound. And the second thing is you have to use keyword arguments. So what does that mean? Well, when you are calling, when you're chain calling like this, you end up always calling the previous method with some arguments maybe. So I've never used arguments so far, but you might want to use arguments. The problem is you don't know exactly which. Okay, so you're always in trouble if you're changing the signature of that common method from one class to the other, because you don't exactly know what parameters to pass, because you don't exactly know which method you're actually calling next. Okay, unless you are very, very careful with the method resolution order. But even then, this could completely change the next time you want to inherit from one of the classes. So the trick is to use keyword arguments, because those are more robust. So if you specify exactly which keyword you're referring to, or which argument you're referring to, then this can get swapped around and so on. You don't have really a problem when you jump from one constructor to the next. All right, so this was a quick introduction to super. This is definitely very complicated. It's definitely tricky to get right and all that. But I hope that by providing this explanation, this live explanation, I can make it easier for you to understand.